We'll have a look at the crossing line too. So if I move forward here, you can see, and you keep an eye on this and on this number, crossing line, that you could see for a short while that it seems like a crossing. So now I'll park on a line, and now the crossing is 20, which of course is true. I have another crossing line, so now it isn't. If I place the robot, let's do it the other way around, like this, you can see that some of the sensor is outside, but it still says crossing. And you can see it thinks the width of the line is from +3 to -1.8. That means 4.8. And down here it says crossing detect, and it has 4.3. It doesn't relate 100%, but it's fairly close. So if I say edit and increase this value to 5.5 and say apply, then it's not wide enough, and now crossing says 0. If I go down to edit first, 4.50 or 59, let's see. So now you can see it goes a little bit back and forth, and that depending on the noise on the sensor, it now thinks that sometimes it's on a crossing line and sometimes not. And you can see it moves from 0 to 20 depending on that noise. So if I move a little bit further, then now it's stable 20. If I move a little bit back, it's stable 0, but of course there'll be some place in between where it's one or the other. And depending on the use, you should find a calibration value that you think works fine. If it detects too many crossing lines, then you could increase it. If it detects too few, then you could decrease it. So 4.9 is probably fine. And now we have made the calibration, save to flash, and we will go to testing it. To testing it, we need a mission. I'll go to the mission tab, and I have already, let's clean up this, already made a small mission, starting with velocity 0, log equals 10. We don't really use the logging here, but it's nice to have some evidence from time to time. And then it will do that only for 20 milliseconds, 0.02. Then the next line says velocity 0.4 meters per second. And I've added an acceleration limit equals 4, and that will make it start a little bit slower. It's not really needed. Let's move it. We will include it again if it's needed. Then an edge L, that means follow the left side of the edge. And if I move the robot, the left side, something like this, and I'll press start again and see if it catches a line. And now it lost a line. It moved there. We will try another one. It means that it didn't really, the software is so that if it detects a crossing while it's following a line, then it will just go straight on. And the idea is that it can pass a crossing line without doing anything bad at least. So we'll go back to this one and then decrease. So it's more this one, edit, decrease this one, 4.2, maybe we could set it down to 4 and say apply. And now it should be less sensitive to crossing lines. We'll go back and it should be sufficiently within the line. We'll try again. That works better. And now it continued, even though there was a crossing line, it just continued, say crossing line, we're following a line, we're not following crossing lines. If I want to stop at the crossing line and go that way instead, then we need to do something else. Then we need the crossing detection. So we will see if we loses the line here, we'll stop, but we'll also stop with a crossing line, and that's called XL. Crossing line, if that's greater than, say, 15, anything up to 20 will do. Syntax check, save to robot, save to flash, then we will try again. So this time it should stop at the crossing line. If I can maneuver it while looking at the screen. This should be okay. And I'll press the start button again. And now it stopped at the crossing line. So basically it's doing what we expect it to do.